Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 5, Lesson 8, Modeling with Systems of Inequalities. Now this is a fairly challenging lesson because really, quite frankly, modeling with systems of equations was a little bit tricky, but modeling with systems of inequalities, although the actual modeling might not be that difficult, the solution and the visualization with graphing calculator technology and all of that can be a bit challenging. So I would suggest I'm going to actually be working with both a scientific calculator today to do some routine calculations as well as my graphing calculator. I'll be busting out of my presentation software at different points in time to show you different techniques on the TI Inspire. So make sure you've got calculators handy, ready to go, and let's jump into it with our first modeling problem. All right, systems of inequalities. There are many situations that can be modeled using systems of linear inequalities. The region in the xy plane that solves the system, the one that's shaded, often represents what are known as viable solutions to the system. In other words, solutions that actually make all of the inequalities true. So let's take a look at exercise number 1. Here we go, exercise number 1. John mows yards for his father's landscaping business for $10 per hour and also works at a bakery for $15 per hour. He can work at most 52 hours per week during the summer. He needs to make at least $600 per week to cover his living expenses. Letter A. If John works 14 hours mowing and 30 hours at the bakery, does this satisfy all of the problem's constraints? All right. So, a constraint is basically a real world condition that constrains you, that makes you sort of go, oh, okay, I gotta do this. So what are the constraints, right? The constraints are that he can work at most 52 hours per week, and he needs to make at least $600 per week to cover his expenses. Those are the two constraints. So if he works more than 52 hours a week, it's a problem. And if he makes less than $600 a week, it's a problem. So I'd like you to pause the video now. You might have to do a little calculator work here to figure out if he works 14 hours mowing and 30 hours at the bakery. Does that satisfy all of those constraints? Pause the video now. Well, the one that's easy is simply to see if he works more than 52 hours per week. He can't work more, right? At most 52 hours means he must work less than or equal to 52. And that's pretty simple, right? Because we can literally just say, well, I've got 14 plus 30, that's 44 hours. That's less than or equal to 52. So that's good, right? That's true, however you want to look at it, good to go, right? Now, the one that takes a little bit more work is to see if he's going to make at least $600 per week. Well, how am I going to do that? Well, I'm going to take those, 14 hours per week, and I'm going to multiply it by how much he makes mowing yards, which is $10 per hour, right? I'm going to take the 30 hours per week and multiply it by how much he makes at the bakery, which is $15 an hour. I'm going to bring out just my simple scientific calculator right now to do this calculation. 14 times 10 plus 30 times 15, that's going to give me 590, right, which I need to make at least, right, $600, and that's actually false. I mean, it's close, right, but the answer is no, right? My two conditions were that I had to work, or not I, but John, had to work less than 52 hours, which was the case, right, 44 hours, all right, and had to make at least $600, but at 14 hours mowing and 30 hours at the bakery, John only makes $590, so that's false, right? He doesn't make enough money there. All right, so now let's see if we can model the inequalities in this problem using a system. Let's take a look at letter B. If X represents the hours John spends mowing, and Y represents the hours he spends at the bakery, write a system of inequalities that describes this scenario. All right, so I'd like you to try this on your own, right? We've given you a bunch of information, and this is very, very similar to writing down a system of equations. The only difference is that you've got these at least and at most scenarios going on. Pause the video now and see if you can model what's going on with a system of inequalities? All right, well, let's first work with the fact that he can work at most 52 hours. That means he must work less than or equal to 52 hours. That's really what we've got here, right, in this first line. What does that really say? Well, it says if I take the number of hours that he mows and I add to it the number of hours he works at the bakery, those two added together must be less than or equal to 52 hours. All right, for whatever reason, John simply doesn't have any more time than that. Now let's do the $600. That's one that's a little bit more challenging, except if I take 10 and I multiply it by the number of hours he mows, I find out how much he makes while mowing. Then if I take 15 and multiply it by the number of hours he's at the bakery, well, that tells me how much he works at the bakery. When I add them together, it tells me how much he makes in total, and that's got to be greater than or equal to 600, right? He's got to make at least $600. So there are my two inequalities. X plus y is less than or equal to 52, and 10 times x plus 15 times y is greater than or equal to 600. If this was a system of equations, we might do something more along the lines of like, John has to work exactly 52 hours. Then that would be equal to 52, and he's got to make exactly $600. Then that would be exactly equal to 600, and then maybe we could solve it by elimination or substitution or something. Anyway, let's take a look at letter C. If John must work a minimum of 10 hours for his father, will he be able to make enough money to cover his living expenses? Show the work that leads to your answers. So remember, John is working for his father mowing, okay? And this problem is saying, look, he's got to work a minimum of 10 hours for his father. Will he be able to make enough money to cover his living expenses? Well, play around with this. You know, you might want to go back to the system of inequalities, or you may even want to just look at the information given in the problem, but see what you can figure out in letter C. All right, well, think about this way. If he has to work a minimum of 10 hours, right, for his father, then the most he could work at the bakery, where he makes more money, right? He makes more money at the bakery than he does mowing for his father. The most he could do would be 42, right? So if x is equal to 10, then y would have to be less than or equal to 42. So the most y could be, would be equal to 42. So let's try that. Let's say that he works 10 hours mowing for his father and 42 hours at the bakery. I mean, again, anytime he spends mowing for his father is less money that he makes because he makes more money while he's at the bakery, right? So let's say he's got, what does he make at the bakery? He makes $10 at the bakery. That's a little bit confusing. So it's going to be 10 times 10. That's the amount of money he'll make at the bakery. Then it's 42 times
15.
Oh, you are absolutely right. I'm sorry. It's 10 times 10 because it's $10 an hour mowing times 10 hours mowing for his father. Thank you, Joey. Then it's 42 hours that he can spend at the bakery times $15 an hour there. Let's see how much money this is, and will it be enough to get past that $600? So I've got, actually, let me clear this out so you can see it a little bit better. 10 times 10, right? Again, 10 hours mowing times $10 an hour, plus 42 hours at the bakery times $15 an hour gives me $730. Since that is greater than or equal to 600, yes, right? So he can easily work those 10 hours for his father mowing. Maybe his father just absolutely needs him to mow, right? And so he can make it, right? He can work 10 hours for his father, 42 hours at the bakery. He'll make $730 in that week, which is greater than the 600 he needs to. Now let's get into maybe the little bit of a trickier part, letter D. Graph the system of inequalities with the help of your calculator on the axes below. Use the space below to think about how to graph these lines, indicate your graphing window. All right, so let's take a look at this a little bit. Right, what I've got is I've got these two inequalities. X plus y is less than or equal to 52, and 10x plus 15y is greater than or equal to 600. I'm going to break out of this just for a moment, and I'm going to open up my TI Inspire calculator. Because one of the wonderful things about the TI Inspire is that you can actually put these inequalities into the Inspire exactly the way they look. So I'm going to do that. Now the way that I do that is I hit my menu, okay? I go to Graph Entry Edit, and I'm going to put in a relation, okay? The first relation I'm going to put in is x plus y is less than or equal to 52. All right, x plus y is less than or equal to 52. Okay, I hit my down arrow. That allows me to put in a second relationship. That I'm going to put in as 10x plus 15y must be greater than or equal to 600. Enter. Now, that's not telling me a lot, right? It's just not doing much for me, okay? But keep in mind what x and y are representing here, right? X is representing the hours that he's at the bakery, that he's mowing, and y represents the hours that he's at the bakery. The most either x or y could possibly be equal to is 52. That's the most. So we can use that to help us think about our window. Maybe what I'll do is I'll make the x max and the y max both equal to 60. Let's take a look at what it looks like in that situation. I'm going to hit my menu. I'm going to go to my window settings. I think I'll leave my -10 there just to give myself a little bit of negative space. All right. Let me go up. Hopefully not have my calculator freak out on me. Again, I'm going to do 60. Very slow. I think I'm going to make that a little bit nicer. I'm going to do y min as -10, and I'll do 60 there as well. Look at that. Okay, right? Now I can really sort of see, if you will, what's going on. All right, I've got x plus y equals 52. That's being shaded down here. I've got 10x plus 10 plus 15y is greater than or equal to 600. That's being shaded up here. All right, what I think I'm going to do is just sort of move this a little bit over here. Bring this down. Don't worry, I'll bring that calculator back out in just a second. All right, here it is. Make sure I open up the right one. What did I have? So I had my y window of 60 here, and a y window of 60 here. That didn't work very well. Let me actually put this on my handheld only so it can stay in front. All right. I've got my one line that kind of looks like this. Okay, and that is my x plus y is less than or equal to 52. Okay, I've got my other line that kind of looks like this, and that's my 10x plus 15y is greater than or equal to 600. Okay, and the actual portion of the plane that is my solution set is right there, right? It's the portion that is overlapping right in there. So everything in here, right, everything in here is my viable solutions. Any point in here is going to be a point that both makes it so that John is working less than or equal to 52 hours because it's below this line, and he's going to be making greater than or equal to $600 because it's above that line. Now you might say, well, why didn't you shade like everything? Well, because I know that this is what's called my viable region, and it's just kind of easier to see at that point, right? Everything inside of here is going to be where John can work and still satisfy both conditions. Let me, for the time being, bring this down here. Okay. Now let's take a look at letter E, and then we'll scroll back up so we can see that graph again. John's father needs him to work a lot at the landscaping business. Show the point on the graph that corresponds to the greatest number of hours that he can work while still covering his expenses. All right, I'm going to do view. I'm going to do a full screen on that. Let's go back there. So what point on this graph? We'll find that point in a second algebraically. But what point on this graph actually represents the greatest amount of time that he can spend mowing while still covering his expenses? Pause the video now and see if you can think about that a little bit. All right, well, remember, these are the hours spent mowing. These are the hours spent at the bakery, right? The greatest number of hours that he can spend mowing while still being sort of in this region is this point right here, right? So all I wanted you to do in that situation was think about that point, right? That point right there is the furthest right, right? The furthest right on the x-axis he can possibly go while still being part of the viable solutions, okay? Now, in letter F, let's figure out what that point is, right? Let's take a look, letter F. Algebraically, find the greatest number of hours that John can work for his father and still cover his expenses. Explain how you found your answer or show your algebra below. Okay, fantastic. So we want to algebraically figure that out, okay? Now what is that? That point is actually the intersection of these two lines. Well, what are those two lines? Those are actually the lines that these inequalities are based on. Specifically, right, we want to find the intersection of x plus y equals 52 and 10x plus 15y is equal to 600, right? That is the intersection of those two particular lines. What I'd like you to now do, and let me move a bunch of these out of the way, I would like you to pause the video now and try to find the solution to that system of equations algebraically. And as a hint, you may want to use elimination. You could use substitution. Some people might even choose to do that, but I think elimination might be the easier way to go. Pause the video now and see what you can do. All right, fantastic. So I'm going to use elimination, and I think I'm going to eliminate x. Although, if I eliminate y, right, because it's x that I really want to find, right? If I eliminate y, then I can solve for x. So how would I eliminate y? If I take this first equation and I multiply both sides by negative 15, then I'll get a negative 15y there that would cancel a positive 15y there. So I think I've rethought it. Instead of trying to eliminate x, I'm going to eliminate y. So what I'm going to do is I'm going to take both of these equations and I'm going to multiply them by negative 15, okay? So for this one, it's going to be negative 15x minus 15y is equal to, now let me bring out actually my smaller calculator here. I'm going to do 52 times negative 15, enter, is going to be negative 780. So now I am just going to add these two together. 10x plus negative 15x is negative 5x. 600 plus negative 780 is negative 180. I'll now divide both sides by negative 5. Let my calculator do that work for me. And I will find 156. That doesn't make any sense because I shouldn't have done negative 780 divided by 5. I should have done negative 180 divided by 5. Yes, divided by negative 5. Anyway, that's going to be x equals positive 36. Like, there's no way he worked 156 hours. He's got to work less than 52 hours. All right, so x is actually equal to, pardon all my errors there, x is actually equal to 36. 36 is the most hours he can possibly work, right, and still be within that region. Now again, one of the cool things about the TI calculator is it will actually find that point for me. I'm going to go back to this sort of two-screen thing. I can still use the intersect command. If I go to Analyze Graph, Intersection, I can actually use the intersect command to find the intersection point of those two lines. And notice when I do so, right, that point is at 36, 16. 36, 16. right? And it kind of makes sense, right? There I've got x equals 36, right? Y is equal to 16. If you think, add those two together, you get those 52 hours, that maximum amount of time that John can work, right? And he just makes $600 at that point. If he goes any further to the right, what happens is that even though he will maybe stay to under that 52 hours of working, he'll drop below the $600 that he needs to make to cover his living expenses. All right, these are very involved problems, right? These can be very, very involved problems, which can make things kind of challenging. And you really want to adopt a mentality on these types of problems that you're really kind of exploring them, right? You're looking at things, you're using various techniques, graphing, algebraic, all of that, to really try to understand what's going on. Now, part of what we want to be doing in situations like this is we just want to be able to algebraically model a system of inequalities given a verbal description of the system. Forget about solving it, forget about graphing it. I just want to be able to model it with the system, okay? So let's get a little bit of practice on that in exercise 2, where we aren't going to solve systems, we're just going to try to set them up. Let's take a look at exercise number 2. For each of the following, write a system of inequalities that models the problem. You do not need to solve the system. Letter A. Dion is putting together a bouquet of roses and daisies. He wants at least one rose and at least 2 more daisies than roses. Roses cost $4 each and daisies cost $2 each. Dion must spend $40 or less on this bouquet. If R represents the number of roses he buys and D represents the number of daisies, write the system. Whew, that's a lot of information given there. Now, let me give you a hint before you begin on this, because I'd like you to try to play around with this on your own. There's actually going to be 3 inequalities that you have to write down. So pause the video now and see if you can work through what each of the 3 inequalities is. All right, well, let's start with the simplest one. Dion wants at least 1 rose. All right, all by itself, that's an inequality. And what inequality is that? Well, the number of roses that Dion buys must be greater than or equal to 1, right? Right away, right? Dion wants at least 1 rose. All right, what's the next one? Well, he wants at least 2 more daisies than roses. Right? Well, if he wanted exactly 2 more daisies than roses, then the number of daisies he had would be equal to the number of roses he has plus 2. That's if he wanted exactly 2 more daisies than he had roses. But he wants at least 2 more daisies than roses, so instead of an equals sign there, it's going to be a greater than or equal to sign. So he wants at least 1 rose, R is greater than or equal to 1. He wants to have at least 2 more daisies than roses, so the daisies must be greater than or equal to the roses plus 2, right? And finally, right, we've got to deal with the fact that Dion must spend $40 or less. Well, how much is he going to spend? Well, roses cost $4 each, so the amount of money he spends on roses is 4R, right? The amount that he spends on daisies is going to be 2 times D, and that must be equal to or less than $40. Right? That's it. That's my system of inequalities. He must have at least 1 rose. The number of daisies he has must be greater than or equal to the number of roses he has plus 2, because he wants to have at least 2 more daisies than roses. And finally, the amount of money that he spends on the bouquet, $4 per rose, $2 per daisies, must be less than or equal to $40. All right, let's take a look at another one. Letter B. A diet food company is attempting to create a non-carb brownie based entirely of fat and protein. Yum. The brownie must weigh at least 10 grams, but have no more than 100 calories. Fat has 9 calories per gram, and protein has 4 calories per gram. If X represents the weight in grams of protein, and Y represents the weight in grams of fat, write the system. All right, well, I'd like you to play around with this one again, but this time you'll have only 2 inequalities that you have to write down. All right, so why don't you pause the video now and see if you can figure them out. All right, well, let's look at the 2 constraints, right? That fancy word, the constraints. The brownie must weigh at least 10 grams, so that's one of them, but have no more than 100 calories. Okay, well, let's do it, right? So this is pretty easy. The first one, it must weigh at least 10 grams. All right, X represents the weight of protein, Y represents the weight of fat. So if I take X and I add it to Y, that must be greater than or equal to 10. The weight of the brownie must be at least 10 grams, so X plus Y must be greater than or equal to 10. All right. Now we have to be a little bit careful here because the X and the Y, you know, they aren't like R and D for Rose and Daisy, right? We gotta pay attention to which one's which. So now we gotta deal with the calorie one, right? This is a diet brownie. I don't know what the point of a diet brownie would be, but it's a diet brownie. So it can have no more than 100 calories, right? So that's going to be less than or equal to 100, however it works. Now, what do we know? X represents the weight of protein. So how many calories are in protein? Well, fat has 9 calories per gram, but that's fat. Protein has 4 calories per gram. So if I take the grams of protein and I multiply by 4, I find out how many calories I have in protein. And if I take the grams of fat, which is Y, and I multiply by how many calories per gram of fat I have, then that's how many calories in fat I have. That must be less than or equal to 100. All right, so this is the one that basically says, hey, when you add the 2 weights together, it's got to be at least 10 grams. And this one says if I take the calories due to the protein plus the calories due to the fat, those must be less than or equal to 100. Now, both of these 2 scenarios could be graphed in a coordinate plane to figure out the viable solutions for Dion's Bouquet or for our nutritional, delicious diet brownie with no flour in it. So let's move on and do one more where we use a graph to think about our viable solutions. All right, here we go. Exercise number 3. The drama club at a local high school is trying to raise money by putting on a play. They have only 500 seats in the auditorium that they are using and are selling tickets for these seats at $5 per child's ticket and $10 per adult ticket. They must sell at least $2,000 worth of tickets to cover their expenses. Letter A. If X represents the number of children's tickets and Y represents the number of adult tickets sold, write a system of inequalities that models this situation. Awesome. All right, well, this is very similar to the last problem, so I'd like you to pause the video now and see if you can write down a system. It's only going to involve 2 inequalities. Go for it. Well, to begin with, right, they only have 500 seats. So if I take the number of children's tickets sold and I add to it the number of adult tickets sold, that's got to be less than or equal to 500, right? I cannot have people sitting on each other's laps, so I've got to make sure that when I add the number of tickets we sell for children plus the number of tickets we sell for adults, it's less than or equal to 500. Now we got to make sure that we raise this $2,000 worth of ticket prices or ticket sales. How do we do that? Well, if I take $5 and I multiply it by the number of children's tickets I sell, $10 and I multiply it by the number of adult tickets I sell, and I add those 2 together, that will be greater than or equal to 2,000. All right? So in one case, I've got this constraint that says, look, I can't sell an infinite number of tickets. The total number of tickets I sell has to be less than or equal to 500. The other constraint says, yeah, okay, I get that, but when I add up the money that I make selling the kids' tickets plus the money I make selling the adult tickets, I have to make at least $2,000. Otherwise, I don't know, maybe the rent on the theater is $2,000, so I got to make at least that just to cover my expenses. Now for the tricky part where we're going to break out the calculator. Let's take a look at letter B. Sketch the solution set to the system of inequalities on the grid below. Use technology when needed. Awesome. Again, this is where that TI Inspire is just absolutely amazing. So let's bust out of this. Let's bring open our TI Inspire again. Let's open up a new document so that we can just start from scratch. No, I don't want to save that. Let's go to graphs. All right, what we're going to do is we're going to move this somewhere where I can hopefully see my two inequalities. That's going to be tough, so we'll just kind of get them in there. All right, I'm going to go menu. I want to put in a graph. I want to put in a relationship. First one I'm going to put in is that one that says when I add the kids' tickets to the adult tickets, that's got to be less than or equal to 500. All right, that's my first relation. Don't worry about the graph so far. Now let's put in relationship 2. That's 5 times the number of kids' tickets, that's the kids' revenue, plus 10 times the number of adult tickets. That has got to be, remember, greater than or equal to 2,000. All right. Again, the graph is amazingly non-instructive right now, and that's because the window is just terrible, right? If I move this over and I actually look at the window that I want to be using here, let me kind of like bring this nice and up here, right? What I see is I see my x-axis and my y-axis going up to 600 in both cases. Now that kind of makes sense. Think about this for a moment, right? I've only got 500 tickets I can sell. The x-axis is the number of kids' tickets. The y-axis is the number of adult tickets. The most adult tickets I could sell would be 500. The most kids' tickets I could sell are $500. I don't even really need to have 600 on the axes, but they're laid out that way. So let's now adjust the window on our TI Inspire appropriately so that we can match this graph. Here we go. Menu, window, window settings. Now I'm going to actually make X-min -100 just so that I can see the x-axis. X-max, I'm going to go 600. And X-scale, I'm going to actually make that 100 because that's kind of the scale on my graph itself. Y-min, I'm going to do exactly the same thing. I'm going to go -100. I'm going to go 600. And I'm going to make my Y-scale 100. That's just how often the tick marks are there. Look at that. Right? There it is. What a cool graph automatically, and we can see that viable region right in here, right where that shading is, okay? So what I'm going to do now, a little bit tricky, but I'm going to put this thing up on my handheld only, all right, which is going to make it a little bit smaller for you. I apologize for that. View full screen. All right, first thing I'm going to do is that x plus y equals 500. Now, one thing I can see about that is I can see that it's got a y-intercept at 500 and it's got an x-intercept at 500, and that makes all the sense in the world because the most adult tickets I could sell would be 500 and the most kids tickets I could sell would be 500, and so I get this line. Now it's a less than or equal to, so I'm just going to kind of, whoops, whatever. My electronic ruler. Now my other one, right, this one's a little bit harder to tell. There we go, I'm gonna move that a little bit down here. That one has a y-intercept at 200, and it's got an x-intercept at 400. All right, so now I can graph that. Excellent. And my viable region is everything in between. All right. And I might want to throw some things up here. We have x plus y. I'm going to just say that that's equal to 500. And then down here, this is my 5x plus 10y is equal to 2,000. Okay, we don't really need our ruler anymore. And we'll put this thing away as well. That's it, right? So everything in that shaded region, anything I put down, if I just like put my finger down anywhere, that would give me a point which would represent, right, x-coordinate would be kids tickets, y-coordinate would be adult tickets. That would be a point where less than 500 tickets were sold, but more than $2,000 were made. Okay? This is the viable region. Any point in here would be a solution to this set of inequalities. Let's take a look at letter C. If the drama club sold 300 tickets to children, what range of adult tickets could they sell and still meet their goals? All right, well, I'd like you to pause the video right now and see if you can look at this graph and figure out what is the range of adult tickets they could sell if they sold exactly 300 children's tickets. Pause the video now. Well, what does it mean to sell 300 kids tickets? Well, here's, right, 300, right? If I kind of had this sort of vertical line here at x equals 300, that would go from right here to right here in the viable solution set. Let me put that in red so we can really see it. All right, it would go from right here to right here. Right, so what adult tickets does that represent? Well, on the lower end, right, that represents 50 adult tickets. And on the upper end, that represents 200 adult tickets. So if we sell 300 children's tickets, we can sell anywhere from 50 to 200 adult tickets, right? And it's right there, right? It's just the segment that goes from that point to that point. By the way, the 200 makes all the sense in the world, right? Because if we sell 300 children's tickets, the most adult tickets we can sell is 200, otherwise we'll go past that 500. Now the lower end is a little bit trickier. What that basically says is, look, if you sell less than 50 adult tickets, you're not going to make the $2,000, right? You're going to be kind of down here. You're going to be in this region that's underneath that line that represents the border of the $2,000 constraint. All right, one last little piece. Letter D. Is it possible for the students to sell exactly 500 tickets and make exactly $2,000? Justify. All right, I'd like you to play around with that question. Can they sell exactly 500 tickets and make exactly $2,000? Pause the video now and see what you can come up with. Well, for this, we're really not talking anymore about a system of inequalities. We're talking about a system of equations, right? We are literally in this situation saying, well, look, I want x plus y to be exactly 500, and I want 5x plus 10y to be exactly 2,000. All right? So if I can do this, then my solutions to this system of equations, not inequalities, but equations, will have a solution that makes sense. Well, this is again another situation that is fairly easy to solve using the method of elimination. So I think what I'm going to do is I'm going to take this first equation and I'm going to multiply both sides of it by -5. And when I do that, I'll just write that new equation down here. That's going to be -5x minus 5y is equal to -2,500. All right, so far so good. When I add these two together to eliminate the x's, we'll get 5x plus -5x, those will be gone. 10y plus -5y is 5y, and 2,000 plus -2,500 is -500. I'll divide by 5 on both sides, and I'll get y is equal to -100. So what does that mean? What does that tell me? Well, it tells me that it isn't possible, right? Because if it was possible, the only way it could happen is if the number of adult tickets I sold was -100. -100. That would be the number of adult tickets that I would have to sell. So it's not possible because you can't sell -100 adult tickets. Now, one last thing before we kind of leave this, right? Really, what I'm doing in that last problem is I'm trying to figure out where this line and this line intersect. And notice, they don't intersect anywhere in this quadrant. I could have actually made the argument just looking at this graph that the answer is no, because this line and this line don't intersect. And in fact, if they do intersect, if they intersect anywhere, right, they intersect somewhere down here, right? That's where they intersect, and that would be at a negative y value, which is exactly what I found in that situation. All right, let's wrap this up. All right, this is a challenging lesson, right? You know, we had to sort through all sorts of words and constraints, and then we had to graph systems of inequalities and look at viable regions. That can be very difficult, and yet it is amazing in the real world how many situations in economics, engineering, medicine, all sorts of things can be modeled by systems of inequalities. So it's important to be able to, like we did in exercise number 2, simply write down the system. Simply just model what we're being told with these systems of inequalities. Then, of course, what we would like to be able to do is visualize the realm or the region in the XY plane that gives us viable solutions to those systems of inequalities, because they'll tell us all the possibilities that we can use to actually solve the system. All right, now don't get me wrong, we're not going to be doing a lot more systems of inequalities in this course, but they'll arise here and there in mathematics and of course in science classes when you need to do this kind of modeling. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.